Hey guys, welcome back to Algebra 2. This is section 5.5, I think. Uh, we're going over example 3, which is using synthetic substitution to find zeros. Remember, zeros are just roots, or where they cross the x-intercept. Um, so we're finding all the zeros of f of x is equal to x cubed plus x squared minus 7x minus 15. And we're going to use those to sketch a rough graph. Emphasis on the rough part. So when we do this, we're going to find the zeros. Oh, let me reset this. Apologize. Uh, so find the zeros. And this question is going to come up. It says, since f of x has a degree of 3, right? That's the highest power we have. We're going to have 3 zeros there. So whatever the highest degree is, that's how many zeros you have, whether they're real, imaginary, or what have you. Now we're determining the types of zeros. So determine whether there's a sign change between each term for f of x and f of negative x, right? So f of x, notice that this is an x cubed and it's positive, and we're going to a positive x squared. So that is no sign change. We're going from a positive to a negative, so that is a yes sign change. And for the last one, we're going from a negative 7x to a negative 15, so that is a no. That is not a sign change. Now, the next one we have is f of negative x. So when we have before is positive x cubed, now it's negative x cubed, because a negative times a negative times a negative is still a negative. That's why this x squared is positive, because a negative times a negative, two negatives make it positive. So yes, there is a sign change. Positive x squared and positive 7. No, there is not a sign change. And a positive 7x to a negative 15. Yes, there is a sign change. Check those answers. Bada boom, bada bing. Got that one. And because there is one sign change for the coefficients of f of x, the function has one positive real zero, one positive real zero, because there are two sign changes of the coefficients of f of negative x. F of x has 2 or 0 negative real zeros. So it's either one or the other. It's either 2 or 0, not both, right? And it's not one. But thus f of x has 3 real zeros or 1 real zero, 2 imaginary zeros. So what we need to do is determine the real zeros. And they made this long table about how to synthetically divide. I will be showing you guys how to do the winner. So it says list some possible values and then use synthetic substitution to evaluate f of x for real values of x. So that's the left-hand column right here. Right here. Each row of the table shows the coefficients of the depressed polynomial and the remainder. I'm going to go ahead and show you guys how to do the highlighted orange one. So when you guys do this, your synthetic substitution, we have a 3. We're going to put that in a box. We have, let's scroll up a little bit. We have a 1, 1, negative 7, negative 15. So we're going to do this. This 1 comes down to a 1, not a 3. Then we do 3 times 1, which is going to be 3. Add those together, 1 and 3, which is 4. Multiply 3 and 4 together, which is going to be 12. Negative 7 and 12 is going to be 5. 3 and 5 is going to be 15. That's how you get your 0 right there. So that's how they did that, and they did that with every single one. What you get down here is your remainder. So that, or your depressed polynomial, which is going to be x squared, 1x squared, plus 4x's plus 5. And that's what they have right there. Cool. All right. Bam. Then use the quadratic formula, figure out, oh, -2 plus or minus I, because they got the square root of -1 somewhere. So that is how you use synthetic substitution to find zeros. They also sketch a rough graph. Boom. The function has one real zero, x equals 3, and the function goes through the point 3, 0. That's saying the same thing. And does not cross the or the x-axis at any other place. Which is kind of, oh, that makes sense. So if we were to draw some kind of rough sketch with this, we have a point right there. Boom, it's going to go something like that, because this is a positive x cubed. I told you something like that. Cool. Talks about end behavior. One common error. Many students incorrectly substitutes value into the quadratic formula, especially the negative b portion. So when you guys are doing the quadratic formula, make sure it's that it's the opposite of the b value. Since our b value here is 4, it's a -4. So if it's positive, it's negative. If it's negative, it's positive. So, all right, guys, thanks for showing up. I will see you guys next video.